Alright, let's get into this week 11 summary. For the topics, just read the stuff here. Reverse chain rule, just to note on that, it's, again, very hard. There's more integration techniques that we haven't done that are also hard, but this is like just having to imagine. This is the hardest one conceptually because you just kind of have to imagine the answer, and then it has to work. So if you can't see it, then there's not much you can do. But with the integration techniques that we do later, it's a lot more like concrete, and you can try a lot more stuff. And as for the binomial distribution, I'd say probability is probably harder, and because you kind of just put the stuff in your calculator. It's in most stats topics, except from probability, you can just put it in the calculator and it works. Right, let's go to the assignment. Let's hope my mic doesn't mute this time. So we'll just hope that doesn't happen. Let's start. So first question, integral, simple stuff. Just use the normal integration stuff. Don't get confused. Just because you're doing a reverse chain rule doesn't mean that you have to use reverse chain rule. It's just done more integration stuff. Next question, we have some discriminant stuff. Not discriminant stuff. We have some factor theorem actually. You substitute 4 in, get the thing that it wants you to. Then substitute negative p in to get this, and the p cubed to cancel out. For part C, find the values of p and q where you have the simultaneous equation, so you can just do this, factorize, get the answer. And next you have the fully factorized form. You don't have to do any division because you can see that the final term is minus 40. So to go from minus 8 to minus 40, you just multiply by 5. And that will be your answer. Then we got some graph sketch. You should be able to see that this is x minus 3 squared. And it will give you this. And then this is just putting x, but this is just f of x minus k. And it's asking basically how do you have to move this graph so that this one of the roots is negative 4. So you either move it 7 to the left, so negative 7, or move it 4 to the left, so negative 4. And then in both of those cases, one of the roots will turn into negative 4, 0. You don't have to do any algebra. This is kind of just deduction. Alright, this question, this is just really, I don't know why they're doing this again. They're doing another question on revenue. This is, you're just substituting stuff in here, I think. Yeah. Yeah, because they're expecting to sell 10 more cushions for every £1 they spend, which means it would just be 10, the gradient. And then you multiply by p to get the revenue, which actually tells you to do this time. And then you have to complete the square, which, yeah, it's really annoying completing that, especially when they put it in this form, which is really annoying. And then this question, you just say the old revenue is this, then you find the new revenue, and then you say that there's a change. The change in revenue is £122.5. Alright, let's speed through these trick stuff. So you could just all you have to do for all these equations, degrees or radians, it doesn't matter. Well, the first 3 you just change the roots and then do inverse. And then for the next one, you'd have to do a little bit of manipulation. For the first one, you do the reciprocal, but it stays the same because 1 over minus 1 is just minus 1. This one, do the reciprocal of both. This one, do the reciprocal of both, and it just gives you the answer. Next question. What have I done? Did I just completely skip? Did I completely skip this? I think I might have. All right, this question 6, looks pretty easy. You just say that tan of x plus pi over 3 is what is this talk? Sorry, I don't really know what I've done here. So they've moved it 60 degrees. I don't know, but you should just be able to substitute stuff in, and then and solve this like a normal equation, and it should give you the right answer. Because, yeah, that's literally it. Sorry about that. Next question, we have some circles. just find, this was really confusing. So find the lengths along the tangents from the given points. So I think what this means is finding this line, but for some reason you had to use Pythagoras instead of just taking away the radii, which didn't make too much sense to me. But you basically just find the radius, find the distance, you find the radius of the circle, then you find the distance from the point to the centre, and then you do Pythagoras on those distances. And you take the long distance away from the short distance, and you do the same for all of them. And then you get your answer. Alright, small angle approximations, we kind of glossed over this in class, so just make sure you remember how to do it. Turn the cos 4 theta into 1 minus 4 theta squared over 2, or 4 theta in brackets squared over 2. And then 2 theta sine 3 theta just turns into 2 theta 3 theta, or 6 theta squared. Next question, we have find sine 75, or what's two values that add or subtract to make 75 that you already know from exact trig, well, 30 and 45. So you expand this. It even tells you to use the formula, which is pretty nice of them. And then you do some numeric adjustments, and then that's your answer. Show that this tells you to use 75 plus alpha, so you just say, how do I go from cos 75 to cos 165? Well, cos 75 plus 90, which equals cos 165, which also, when you expand it, equals negative sine 75, so there's your proof. Next question, we got some functions. I hate these questions because they take ages. I didn't actually write 10, but it's fine. This is the range of cos x is -1 to 1. And then you have to find the inverse, and just it's basically wanting you to say, like, to realize that the inverse of a function, the domain and the range just swap around. And then for this, gf of pi is just pi because it's arc cos of pi. When you have the inverse function of an inverse function of a number, it just gives you that number back. But contrary to what I just said, explain why fg of pi is undefined, because even though you should just be able to cancel this out, if you actually go through and do this, arc cos of pi, I mean, technically this, according to this, it's not really undefined. It does actually equal pi, but because you have to use like complex number stuff to be able to do that, so they just say it's undefined. Or here they just say it's undefined because pi is outside the domain of arc cos theta. Next question, we have this cross section. This took me a while to figure out what it was. It's just a pipe where this is the radius here and then this radius is t, and you say that the area of the cross section is going to be pi times this radius minus this radius here. So it's a pi times 2 squared minus 2 minus t squared to find this bit here. And then you expand, do the thing. Then you differentiate. You can ignore constants, so you can keep this in the bracket. And then you get your answers for that, because, you have to just substitute a quarter in and then substitute a half in. Yeah. Next we have, I don't know why this isn't a different question. But anyway, so you have this piece of wire that's cut. You say that this would be 4 minus 2x. Because it's just 16 minus 8x, but you can like bring it down a bit. And then you say that like all of them put together, so the areas, if you add the areas together, then they make 16. And then that's how you can show that quadratic here. And then you solve the quadratic. And then also substitute it back in. All right, next question. We have an integration question. Ignore this drawing because I read through it later. You differentiate, substitute to find the normal gradient and the tangent gradient. Go and find the equation that they want, and then I redraw it here. This is the area we're finding. So I said there's the area under the curve here plus this triangle, which we find all the points by, and that means you do the integral, compute this, and then that is your area. Next question, we have some trig stuff. So I don't know why I wrote it this weirdly, but what have I done here? So I rewrote 1 plus tan squared as sec squared, and then 1 minus tan squared as 1 minus sine squared over cos squared. Then combine the fraction to get sec squared over cos squared minus sine squared over cos squared. And then you can rewrite this as 1 over cos squared, so sec squared, times by the denominator, or times by the reciprocal of the denominator, just because that's how you divide fractions. And then the causes will cancel out, and then cos squared minus sine squared is just cos 2x, and that becomes sec 2x. Next question, I just combined the fractions, and then it became what I wanted what I wanted it to become. Next question, you get all the 2 thetas, and I expanded. You actually do when I saw this question for the first time, I thought you wouldn't have to expand the 2 thetas until the end, but actually you could just expand them and everything cancels. And then you get your answer. Part D was interesting because when you expand it, you get this, which looks like you're not going to get the answer, because when you have 15 sine 2 theta, but you have a different number of cos 2 thetas. But then you remember that cos squared theta is 1 plus cos 2 theta over 2. Substitute that in, and then your constant value will become 17, and then that'll give you your answer. Next question, this one, I just combine the fractions, and then eventually it gives you your answer. Because cos 2 theta is cos squared minus sine squared, plus sine squared, the sine squareds cancel, and then you get just cot theta in the end. Now this is really easy because it's just reverse of, so this is just sine 90, this is just sine 60, this is just tan 60, and this is just tan of pi over 4, and then this one, you say that this is 2 times, you see you think here, well, there's nothing behind the sine, and there's a root 3 behind the cos, so surely I can't use compound angle, but if you take a 2 out, it becomes root 3 over 2 cos 15 minus half sine 15, and you say that root 3 over 2 is sine 60, half is cos 60, and then that simplifies, and you get 2 sine 45, which becomes root 2. Now this question was very interesting because there's probably an incredibly easy way to do this, but I just kind of didn't do that way of doing it. If you look at what you can take a look at what I did. I said that there's like the decays of all the digits of the number that can be in this set, and then I expressed them as sums of each other, and then I used this formula that we're going to learn to set them equal to each other, and then I proved it. But there is definitely an easy way to do it, so I would just use Gorth on that one. Next, but let's go on to section B. I need to take a water break. Alright. Jesus. So we have this thing, area of A1. So we know the big area of OEF is 64 theta, and then the area of everything except A1 is 2 plus r squared, or 2 plus r squared theta. So you can factorize theta out and get that, and then expand, and then cancel. Next question, given that equals 7 A2, so you find A2 in terms of r and theta, and then everything will cancel, you get your quadratic, and then you have your answer. That should be -3, not 3. The answer that I crossed out. Right, next question. They always love doing this, where at the start of any model question, they give you some constant you have to find by saying that at the start, they give you a model in terms of time. They say when this model begins, there's 300 orchids, like when the study started, and you just have to like infer that means when t equals 0. And then when you substitute t, you can find the value quite easily. Then for part B, show that use that equation to show how many years until it reaches 1850. So you just set it equal to 1850, solve, and it'll give you like 13.8 or something, which is 14 years. And then next question, this is something when I saw it, I thought that they wouldn't actually do something like this, but apparently they did, because you have to multiply both sides by e to the negative 0.2t of this thing here, obviously with the a substituted in. And then so it's kind of like when you're doing rationalizing the denominator, where you're taking all you're getting rid of some e's. But technically you could actually, I mean, if you had no idea what to do for the second question, actually no, technically if you had no idea what you were doing for the first question, you could technically to work with this thing. But anyway, then so you just multiply by e to the negative 0.2t, and if you know how that you should do that, then it's easy. But obviously that's not an easy thing to figure out. And then you show that it can't exceed 2800. Well, when the maximum value of this p is when the denominator is the smallest, and the denominator is the smallest when e to the negative 0.2t is 0, because it can't be below 0. Therefore, the lowest value would be the highest value. Sorry, of p would be 336 over 0.12, because we're just assuming that e to the negative 0.2t is 0, and then you do that, and it's 2800. Right. Next question. This is just an easy kind of like vector question. There was a more difficult one later on. You find the vectors, modulus all of them, and you just say it's scalene, because usually it will be isosceles, but I guess they just wanted to trick us off this time. Next question, we have some probability stuff. This is a pretty relatively easy one because you can find literally the entire Venn diagram instantly. So you just get the probabilities, do the probability thing, and then you just say that they're not independent. Therefore, the teacher's suspicion is correct, or whatever, something like that. So this question, actually, they have put a few questions in this before. I didn't want to talk about this because, like, it's technically we do it next year, but it's such a simple thing that they don't explain that for some reason is in Further Pure 1, or I think it's Further Pure 1, maybe it's in Core Pure, I'm not 100% sure. But there's a chapter on inequalities and just equations like this where you have a function on a denominator, and if you just multiplied by this, you wouldn't be able to do this. So it wouldn't give you all the solutions. So what you have to do when you have a function like this, where you have something on the denominator, and you have to find an inequality or solutions, what you do is you multiply by the square of the denominator. So you multiply this both sides by x squared minus x squared. And then what you do after that is you just expand, the x cubes cancel, factorize x out, that's one of the solutions. And then you can see just by deduction here that x equals 1, because 1 minus 2 plus 1. Then you do the algebraic division, and then you can see that x equals the golden ratio and 1 minus root 5 over 2. The golden ratio is just 1 plus root 5 over 2. But it's always fun to see it, and it's always fun to write it out like that. But the golden ratio is just 1 plus root 5 over 2. So you get these solutions, and then I drew out the quartic. So the equation that I got was that x to the 4 minus 2x cubed plus x is greater than 0. Even though here it says less than 1, you get the equation that you've created, because this is just equivalent to this equation. So this equation is greater than 0. So I drew out the quartic with all the solutions that I found. And it's greater than 0 when it's less than 1 minus root 5 over 2, when it's greater than 1 plus root 5 over 2, or in between 0 and 1. And then those are your inequalities. Next question, I never thought I would see one of these again until the actual exam, but it's just another one of those SUVAT questions where you get 2 different points, and you do A instead of, because they give you A, B, and BC. They give you information about A, B, and BC. What you have to do is you have to use A, B, and AC. That means the initial velocities will be the same. Therefore, you can solve simultaneous equations of both of them, and then you just get the answer to these answers. I'm sure you've seen these questions before. It came up on tracking test 2, so I'm sure this shouldn't be a problem. Next question. This is some vector stuff. So firstly, we just use this formula here. You get t equals 3. Then next question, you substitute 5 in, and then you take the modulus of it because it says speed, which is a scalar. Then find the angle that it makes with this. So here I use something called dot product, which we're going to be learning in next week, which is actually part of second year content, but we're learning it early because you can use dot products everywhere in vectors, and it makes most vector questions much easier. So don't worry about this question, because in a couple weeks time or next week we're going to know dot product, so it's fine. Next question, we have projectile. Again, we've done loads of these before. You do the x SUVAT, the y SUVAT, do the trig ratio, and then this is s equal when acceleration is 0, s equals ut, easy first question. And then the vertical height is just the you use s equals ut plus half at squared on the vertical bit because t is 4. It kind of just gives you all the values here. You don't really need to do much. All right, next question. We have an inclined plane. So it's it's moving up the plane, so there's friction down the plane. You resolve your weight components. You resolve the string that's 15 degrees to the plane, and then you also draw your r. draw it on your cross diagram, resolve perpendicular and parallel to the plane, and you find r, you find mu, and it asks you for the frictional force. Now, because it's part A, I feel like the frictional force might be, there might be like a different way to find this, but I know the frictional force is just mu r, so I just multiplied the two values I got, which gave me 16.89, which is correct. So, I don't really know how else you would find this, but that is a way to do it. Next, we have a tree diagram. These tree diagrams from GCSE, really not that interesting. I like the context here. It's pretty interesting context with like the disease and the population. It helps you like kind of visualize what we're actually doing in stats. But it's just some simple probability stuff. For this part, I should have just done, I did 1 minus like the other case, but you could have done just the case that it was asking. And then I said, you say that the test isn't useful because it gives false positives. Next, we have this rectangular box. It has no top, so it's only, the area is going to be x squared h, that doesn't change. But the area is going to be x squared, which is the base, plus 4 times, so 4 times xh, which is the other 4 sides. It would, if there was a top, it would be 2x squared plus 4xh, but since there's no top, you take away one of the x squareds. Then you substitute the thing that you got in, and then you get what it says. And then normal stuff, it's just optimization. And then, yeah. Now, when I saw this question, I was really like, oh no, it's not going to be good because it's histograms, and I hate histograms. You literally, it just asks you from 78.5 to 90.5. I don't even know why it says this, because you can tell that it's just 12 times 1, because the frequency density is 1, and the class width is 12. So it's just 12 times 1, and that's literally the entire question. Next question. This is an interesting question, actually. So what I've done, I've drawn the, you can see from the origin, I've drawn the paths to the different vectors, and that this is the midpoint's easy to find, and then the position vector of D is just kind of in between A and C, so you can find, it's like the midpoint of B, the same sum of the same components of that with the sum of the same components of A and C. So as the same J component as, no, not the same J component, the same J component as D. What am I talking about? Sorry. Yeah, it's just, you just kind of combine, you find where these two vectors intercept each other, and then that gives you your answer. Next, we have this, it's another dot product thing, so don't worry about this. And then this is actually a good way, that I don't know if we learned this, but this is a good way to find the area of a parallelogram. You just do the two vectors that are next to each other times by sine of the angle between them, which will give you the answer. Next, we have this question. This is interesting. I don't think I would have got the marks if this was actually in an exam, because I didn't use the exact values. Since this, there was an alpha, and there was also a 90 minus alpha, so I didn't want to use exact values. So I kind of just said that the angle is 37, and then the 90 minus the angle was 53, then resolved all the forces, put them on the cross diagram, and then resolved. And then it gave you this. Now this question's already come up in a previous one. I don't know how they've done it again. You just know that, so you can separate summation. So the sum of t, which we're going to need, subtract the sum of 5 up to n. So the sum of 5 up to n is just 5 times n, because it's 5 added on itself n times. So it's just 5 times n. And then that means sum of t is 55 plus 5n. So and you know that sum of t over n is mean. So 10 equal the mean equals sum of t, 55 plus 5n over n, and then you solve for n. Then obviously when you're converting that into knots, obviously you multiply by 20 over 23. You should be remembering this stuff by now. Obviously I'm joking. Next question, compare the average daily wind speed. You just say that it's less. And then the reference, the one thing that I would always remember about the large data set, as much joking as I do, is that it covers from May to October. That's the one most important thing in my opinion, because it's the easiest piece of information to remember, and it comes up probably the most out of all other things. And then this is just considering outliers. Right, thank you for watching. I will see you next time.